All right, let's solve this question. And the question says that the sum of the first two terms of a GP, now a GP stands for what? Geometric progression, is x. And the sum of the last two terms is y. Now there are n terms in this GP, so we have to find the common ratio r in terms of x, y, and n. So how do you solve a question like this? The first thing is to write out the series of a GP. Now, for a series of a GP, the first term is a, plus the second term is what? AR, plus the third term AR squared, plus, and that continues, plus AR cubed, plus AR raised to the power 4, down to the second to the last term, AR n minus 2, then plus the last term, AR n minus 1. So this is the series of a GP. Series is gotten by what? Adding each element or numbers in the sequence of a GP. Now let's go back to the question and see how we can use this to solve the question. Now it says the sum of the first two terms. Now this is the two terms we're going to work with. So it means that the sum of these first two terms, which is a plus AR, is equals to what? X. Now if you factorize, a is common, so you have a into 1 plus r is equals to x. This is your first equation. And the sum of the last two terms, so we're going to work with this also. So the sum of the last two terms is what? AR n minus 2, plus AR n minus 1 is equals to what? Y. Now we can factorize this. A is common, so you bring out your A. Now what is, we can also factorize this term. Now if you look at it, r raised to power n minus 2 is common. You are left with what? 1 plus r is equals to y. If you are confused about this, try expanding the brackets. You will say that r raised to power n minus 2 times 1 is r raised to power n minus 2. R raised to power n minus 2 times r is what? R raised to power n minus 2. Then the power, since the base are the same, the powers you just add. Minus 2 plus 1 will give you minus 1. So this is the factorized form for this. Now we have this as what? Equation 2. Now remember the question says find the common ratio in terms of x, y, and n. So what do we do? So if you look closely, if we divide equation 2 by equation 1, what will you notice? You'll notice that your y, which is equation 2, divided by x is equals to what? AR n minus 2 into 1 plus r all over your x, which represents what? A into 1 plus r. Now, y over x, because the common ratio is usually the second term divided by the first term, or the third term divided by the second term. So we're going to use the sum of the last terms divided by the sum of the first terms, or first two terms, and the last two terms. So the sum of the last two terms divided by the sum of the first two terms, not the other way around. Is that okay? So what can we do here? You can see that we have common terms or like terms. They cancel out. A and A will cancel. 1 plus r and 1 plus r is going to cancel. So what are you left with? You are left with what? Y over x is equals to what? R raised to power n minus 2. Now, how do we make r the subject of formula here? Remember, for your laws of indices, if you have x raised to power a is equals to b, you can actually what? Raise both sides to the reciprocal of a, so that A and A will cancel, so you are left with what? X is equals to B raised to the power 1 over A. So we can do the same for this above. So it means that I can raise y over x raised to power the reciprocal of n minus 2, which is 1 over n minus 2, is equals to what? R n minus 2 into 1 over n minus 2. What will happen? You see that n minus 2 and n minus 2 will cancel out. So you have r raised to power 1. So your r is equals to what? Y over x raised to power 1 over n minus 2. So that is your common ratio in terms of what? Y, x, and n.